Sarah, thank you so much for joining. So this is again an example of basically what I did at the beginning of like 5 weeks ago is I asked many of you, hey, what are you interested in discussing? And then I got a bunch of really good recommendations, including the one from Sarah that she'll give a little bit of an intro into. And she basically proposed to discuss as this group on immunosenescence therapies.
So there's a sort of a natural question about, is there an intersection between the kinds of therapies people have been working on for aging and for COVID-19? Now, why would you expect there to be such a thing? Because COVID-19 is a disease of the elderly. People are much more likely to get it, much more likely to die from it the older they get. And the failure of the immune system to handle infectious disease increases dramatically with age. So basically, we have far fewer T cells as we age. The size of our thymus, which makes the T cells, shrinks, starting from when we're 1 year old, but it shrinks dramatically as we age. The immune response to a vaccination diminishes as we age. This is a big problem because one of the leading killers of the elderly is respiratory tract infections like influenza. But if you try to give a flu vaccine to an old person, they don't have the same kind of a strong antibody response that young people get. So they have to rely on herd immunity and sometimes some adjuvants, sometimes higher doses, but they just won't get immunized as effectively. So that one of the questions about when people are trying to develop COVID-19 vaccines, the first tests of those are going to be on healthy young volunteers, and they may not even be effective, even once they're approved, against the elderly, who are most of the victims of COVID-19. So the same kinds of interventions that it seems might be effective against immunosenescence generally, against the decline of the immune system, might be applicable to COVID-19, to preventing it and to avoiding some of the more serious sequelae. So I'm open to different suggestions, but I just wanted to talk about a couple of the avenues out there. One sort of branch of these things has to do with pulmonary fibrosis. So pulmonary fibrosis is when you have fibrous lesions in the lungs, which of course don't function and they don't grow back. They're permanently damaged. This happens to some degree in everybody as they age. It happens younger and more severely in a disorder called idiopathic pulmonary fibrosis. And it happens as a result of ARDS, of acute severe respiratory distress, the thing that happens to you when you get a very bad case of pneumonia or COVID or any other kind of lower respiratory tract infection. When you need to be on a ventilator, lungs get damaged. A good percent of people get permanent pulmonary fibrosis. And the scary thing is we don't know in the particular case of COVID-19 how many people are going to get long-term permanent sequelae. We know that about 17% of people who come into the hospital and get a CT scan for COVID have some signs of fibrosis, but the permanent thing, you have to wait until lots of people have recovered and see how many of them still have symptoms months and months later. But it did happen to a small percentage of people who had SARS. I believe single-digit percentages of people who had SARS had long-term lung problems. Now, the good news is that the aging community can do something or it has been doing things for pulmonary fibrosis, because it seems to be actually caused by cellular senescence. And there have been a number of experiments that show this in some different ways. If you take senescent cells and put them in a lung epithelial cell culture, they become fibrotic. Their secretions stimulate fibrosis. So there's a causal track there. And if you go the other way, if you selectively kill the senescent cells in the lungs, whether by a genetic kill switch or by a senolytic drug that kills senescent cells more than it kills other cells, like dasatinib and quercetin, or doxycycline, those will really quite dramatically reduce the pulmonary fibrosis. They don't make it go away entirely, but they reduce the percentage of tissue that is fibrotic by about half, 40%, half. So that's a thing that probably should be investigated in human trials for COVID-19 right away. There have been pilot studies of dasatinib and quercetin in patients with idiopathic pulmonary fibrosis, where it had favorable side effect profiles. You're already giving everybody who's hospitalized for severe COVID drugs that are comparably side effect heavy to some of this stuff. So it's a reasonable, from my, I'm a layman, but it seems like it could be a reasonable risk trade-off to be worth some initial experimentation. Certainly, you could start in animals. So that's sort of the pulmonary fibrosis angle. Then there's a completely different angle that has to do with prevention, with targeting the immune system directly. And this is a bit more speculative. Less of it has particular application to COVID. But some of it is just very broadly interesting. So there are a couple things that seem to do something about immunosenescence in animals and sometimes in humans. One of them is immunostimulants, things like Bacillus calmette-guerin, BCG vaccines. They don't just protect you against these bacterial infections. BCG is a bacterium that's full of lipopolysaccharide. That is the stuff on the cell walls of bacteria that is a really powerful antigen. It's super immunogenic. And when you have that innate immune response jacked up, that can do lots of things. It's already a standard treatment for bladder cancer. You put some bacteria up in there, and the immune system more vigorously attacks the bladder cancer. It already has some effects on increasing antibody response to influenza, reducing the incidence of respiratory tract infections if you give elderly patients a BCG vaccine. And then there's this interesting correlation study that a lot of people have been talking about, which is people who live in countries where the BCG vaccine is standard are less likely to get COVID-19. Correlation's not causation, but the experimental randomized controlled trials seem to bear out that BCG vaccines have some nice favorable effects on viral infections as well. And that again, it's safe. They give it to healthy people all the time. It's in the realm of things that could make sense to do a trial of on healthy people before they get COVID. There's some other stuff that's a little more out there. So DHEA is a little bit controversial. DHEA seems to reverse some signs of immunosenescence in animals. They tried it on elderly people for influenza, and it didn't work. And that seems to have been largely the end of it. But DHEA is a male hormone that declines as we age, and there was the thought somewhere in the 90s that if you resupplement it, it could prevent some of the effects of aging. And I don't think that's. I think a negative result is maybe it doesn't tell you everything you need to know for all viral infections, but you know that has sort of stalled because of those early negative results. And then there's weird stuff. You know how you can completely reverse thymic involution? Castrate a male mouse. The aged mouse gets its thymus right back up to normal levels. Now, women and female mice also experience thymic involution, so this can't be the whole story. But this is a very dramatic effect. I would not go so far as to say let's go around chemically castrating humans just because they might get COVID-19. But there is a little bit of a additional motive for finding out, well, how does this work? What changes? Go ahead.
I mean, yeah, to avoid COVID-19, it sounds ridiculous, but regrowing a thymus has other uses, does it not?
It has lots of uses. A lot of people like their sex hormone balance the way they like it. So the intriguing thing here is not to replicate the surgery or the very blunt instrument drugs in humans. The interesting thing that I think deserves an animal study is do that surgery and then look in a lot more detail transcriptomically, look in a lot more detail of in the thymus tissue, what changed? And is there something more narrowly targeted that you could then do that would not, change a human's entire appearance and fertility? But there's definitely a very powerful effect in there. And we know how to do it. We just don't necessarily like the side effects. That's more of a long-term project. That's probably not going to hit anything during the COVID time period. But it's the beginning of something that I think could be somewhat motivated by our current crisis. The other thing, which might be even a little bit more short-term and is still in the weird zone, is so you lose T cells as you age. T cells come from the thymus. You lose most of your thymic tissue as you age. What happens if you put in new thymic tissue? And the answer is, if you're a mouse, you have more thymus, you have more T cells. Your T cells proliferate better in response to antigens, and you live longer. You live about 20% longer. Now, the trouble with transplants in a context of infectious disease is that you have to put people on horrible immunosuppressants. But there is this weird 2014 paper from Russia where they do the transplant in the eye. They do the transplant in an immunologically privileged compartment in the eye. So they don't actually have to give them. And it's their own, preserved young cells. So they don't have to give the rats a bunch of graft versus host rejection prevention drugs. So is this crazy to do to a healthy person? Probably. Is it worth replicating in an animal? Yeah. Always good to replicate these weird Russian studies in the West. That's one of the things we do at LRI. And the paper does not say whether the rats go blind, but I don't. As I recall, there are some other immunologically privileged locations in the body that you need less for your vision, and there may be a world in which you could just, give your immune system a restart with some surgeries once we can figure out how to make them relatively non-invasive and non-risky for a healthy person. And then the other thing is even more feasible, even more manageable is mesenchymal stem cell transplants, which you can again do from your own youthful cells, and they do seem to reverse immunosenescence in animals. a lot of what they've been studied for is in the context of preventing and treating autoimmune diseases, which sounds like it's going the other direction, but it's kind of not. You kind of have this Th2 direction shift as you age, where you are producing less of the kinds of T cells and cytokines that help you fight external infections, and more of the kind that hang around and make you eat yourself. There may be a world in which stem cell transplants are something that one might do periodically, or various kinds of autologous modified adaptive transfer of immune cells. There's one that's actually being tried right now as a COVID vaccine. Vaccine being used very loosely because it is in no way a killed extract of the COVID-19 thing. It's your own T cells activated in certain ways, genetically modified in certain ways, so that your overall immune system is stimulated. So there may be immunomodulators that are, they call them vaccines because that makes it sound normal, but they're really just generic immune rejuvenation things that are actually hitting trials in the context of, as COVID prevention. That's a whole world. There's a lot of things you can do to transplanted immune cells and mesenchymal stem cells, but there's certainly an enormous appetite right now for things are hitting human trials faster than ever when they are classified as vaccines for COVID. So it would not at all be unreasonable to start messing around with some of these transplant things. Regrowing thymus. Regrowing thymus is a thing. You can do it with fetal or newborn thymus transplants. I have half in mind the next time there's more FAST grants available or something like that, to put in an application for doing this on ferrets, seeing if a young thymus transplant will actually reduce the susceptibility to COVID-19 in an aged animal. Greg Fahy. Greg Fahy has been doing, I forget, is he starting?
Greg, you're here. Would you care to say a few words?
Sorry. Yeah, what are you up to?
Muted.
Unmuted now?
Yes.
Hi.
Hello. Welcome.
Yeah, I'm sorry. Hi. Well, thank you. I had difficulties logging on, so I missed almost all of the discussion up to this point, unfortunately. I was really looking forward to it, but I was prompted for a password I didn't have and blah, blah, blah. But anyway, here I am. Before I say anything, I just want to say that as far as Lifespan Research Incorporated is concerned, it's very interesting coincidence that around the year, 1983 or so, I started a company called the Lifespan Company, and its concept was almost identical to LRI's. I actually set up a mouse longevity study in an office building in southern Florida. It was completely illegal. We weren't zoned for that kind of research. I had no permission from anybody. We had to take out the window on the 5th floor because the building elevator was too small for mouse cages. So we hauled up the mouse cages up on the outside of the building, 5 stories, and installed them. And what we did is we fed a bunch of mice various things that had been reported in the literature to extend lifespan. And the idea was to market nutraceuticals that worked, and with the money from that, do more lifespan studies and just keep going on from there, and include drugs that could be repurposed for anti-aging purposes. And I see elements of all of this in LRI's website, which I checked just before this meeting. So I think good ideas come back eventually.
Yeah.
And so I think you have the right idea. We just couldn't make it work at the time. And the guy who was paying for the research was a coke addict, and eventually the Drug Enforcement Agency rappelled down the walls of the building and kicked the window in and hauled him off to jail. Unfortunately, I was not there at the time. But in any case, I'm glad that you were able to revive the idea.
Yeah, no, thank you. Just for the record, what we're doing is legal.
Yeah, I'm sure that it is. You're actually doing it in the right way. We were doing guerrilla science at the time.
Look, I totally approve of guerrilla science. You can make it work.
Sometimes you got to do what you got to do.
So
Yeah.
can I just say that since you missed it, Sarah spent the last 15 minutes or so kind of briefing us on a whole variety of historical and present approaches to T-cell and particularly thymic regeneration, but I don't think she focused on your stuff. Then someone asked about your stuff, and then Allison said, hey, look, he's on the call. Let's ask him.
Okay. All right. Fair enough.
Maybe a good question is, how does yours differ from like a lot of previous approaches that have looked at the thymic regrowth and augmentation?
Right. So one way in which it differs is it's practical, and it doesn't have much in the way of downsides. So I did catch the part about castration of male rats and things like that, and that's quite true. That whole story has been a mixed bag, though. There has been one study, at least, in which castration regrew the thymus but did not restore immune function. Mm-hmm. So it doesn't do much good to restore a non-functional thymus. And also, many of us would prefer to avoid castration for some reason. So there are interesting angles on that we might be able to pursue at some point that would not have such drastic side effects, but might accomplish the same things. But we don't have any data on that so far, so it's premature to talk about anything like that. Mm-hmm. So when I came up with the protocol that I came up with, it was selected for a couple reasons. One is it doesn't have those kind of drastic side effects. Therefore, it could be accepted by a large number of people. And two, it had actual human evidence. So there's no other treatment except for a variation on this castration business that has any human evidence of efficacy. And the variation on the castration business requires total body irradiation, to destroy your bone marrow first, and then you can get somewhere with it. And that's good if you're going to have your bone marrow killed off anyway, but not if you want to restore your immune system. That's not really the right way to do this. Mm-hmm. So the way that I approached it is to essentially reverse the aging of the thymus. Mm-hmm. What I didn't know at the time is that it looked like it might reverse the aging of the body more globally, although there was some reason to imagine something like that might happen. But the thymus is a really, really interesting case within aging research. It's usually overlooked for its significance in more ways than one. For one thing, for many, many years, it's been ignored as a factor in age-related morbidity and mortality because the effects of thymic involution are delayed until after about the age of 65 or so. Mm-hmm. So if you measure the immune system of a 60-year-old and of a 20-year-old, you don't really find much difference. And so people would say, well, it doesn't matter that the thymus involuted. It's not a big deal. But if you go back and measure the immune system at the age of 80, you're down, to 2% of your 20-year-old ability to recognize foreign invaders. So that's one way it's been overlooked. But this more salient way is that it's been overlooked for what it means in terms of what aging is and what drives aging and how aging works. And that is that the thymus is the first organ in the body to show any age-related change. And it shows age-related changes starting about the time we go through puberty. And so during puberty, all these sex hormone things are changing. And in fact, during that time, your sex hormones are going up. And that does go along with the castration to improve the thymus. And when women get pregnant, their thymus involutes a little bit more. And when the pregnancy is over and the baby is delivered, the thymus rebounds somewhat. It regrows again. So there's certainly a relationship between thymic state and sex hormones. But the main theme is something different from that. So the thymus is actually programmed to begin involuting as you go through puberty. And the detailed molecular biology of that is pretty well worked out, actually. And yes, sex hormones are a factor, and things like growth hormone and those sort of things are a factor, but there are deeper biological issues. And that's why, so I did hear the part about transplanting thymic progenitor cells or precursor cells or thymic epithelial cells from different age animals. This is the reason that doesn't work. Now, it works in a very, very narrow context. If you can get a rat thymic cell of exactly the right age, plus or minus maybe a half a day, and transplant it into the thymus, yes, then what you just heard is true. It will reconstitute the thymus and you can get somewhere. But any other age doesn't work. And there's a reason for that. And that is that age thymic cell is programmed for thymic growth, and all other ages are programmed for thymic involution, or at least not for thymic growth. And so if you take a young thymus from a syngeneic old rodent, say a syngeneic old mouse, and you put it into an old mouse, it will work for a little while, and it does wonderful things in that short time that it's around. But after about a month, it will re-involute, and you'll be right back to where you started from. So it's not that the thymus is damaged. There's nothing wrong with the thymus. The problem is that the body doesn't want your thymus around anymore. Your body wants your thymus to be involuted, and transplanting the thymus is an exercise in futility if you don't deal with the fact that the aged environment is not a pro-thymic environment, it's an anti-thymic environment. And we can argue about why that might be, but that gets into teleology, and it's unimportant. The only thing that's important is what actually is. What is the reality? And that's the reality. So if you want to regrow the thymus, you have to oppose nature. You have to reverse the program. And so there's really only one way that I know of that's easy to do and has a large amount of human experience to back it up, that you can use in order to reverse that program, and that's to use growth hormone. Now, you can also use IGF-1 by itself. If you're a cat, for example, you can regenerate your thymus all by, all with IGF-1 alone, okay? But you really don't want to give IGF-1 to people for all kinds of reasons. It's not practical, it may not be safe, blah, 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 blah. Growth, and it has the problem of any drug. You give a drug, what happens? The bloodstream levels of the drug go up and then they crash, right? And that's not what happens in your body normally. In the body, normally you have your growth hormone levels go up and crash, but your IGF-1 levels stay constant. So if you want to regrow the thymus, you want to do it the way you grew it in the first place, which is in the context of a youthful environment that's pro-thymus. And it turns out that part of the youthful environment is growth hormone, because after all, how do we get to puberty in the first place? We get to puberty in the first place by growing. We start off as babies and we get to be adolescents. That's a lot of growth. That's more growth than in any other time in your life, and you need growth hormone for that. And right along with the growth of the rest of your body, you're growing your thymus. So this is what makes sense to me. And there are other factors like IL-7 and things like that you can use, but they're just not very practical without genetic engineering. And if we want to use genetic engineering to regrow the thymus, then we're talking another 10 years. And meanwhile, we're all dying of thymic involution. We can't really wait that long. So I decided that we needed to use growth hormone, but uniquely, I recognize that growth hormone has bad effects. It has this diabetogenic effect, and I worried that that might have a pro-aging effect. And I think the evidence now tends to support that. that if you give, so first of all, a lot of people are worried about growth hormone as being a pro-aging factor, because if you create mutant mice that are deficient in growth hormone signaling, they live longer. But what nobody really tells you is that, yeah, they live longer because they're in a germ-free environment in a laboratory with a controlled temperature. But if you were to take those mice and put them in the wild, they die almost immediately of immunosuppression and also of hypothermia because they don't have enough energy to maintain their own body temperature out in the wild. So these are debilitated, weak mice. They look horrible. They look wrinkled. They look awful. So they're a freak experiment, and they don't really inform us of what we need to do in adult humans, okay? So in adult humans, so what are you doing when you're young? When you're about a pubescent person or just pre-pubescent, you're running around like mad. You're not only growing, but you're bursting with energy, and you have lots of growth hormone, and you're growing your thymus, and you also have a lot of DHEA. And so I tested this idea that I came up with on myself, that one hidden function of DHEA is to block the side effects of growth hormone. And so if I dosed myself on growth hormone for a week and then measured my IGF-1, it would go up and everything would be fine. But my insulin would go up also. But if I continued the same regimen for another week in combination with DHEA, my IGF-1 would stay up, but my insulin would go back down to a baseline. So it turns out that worked in our clinical trial as well. And if you look at correlates between longevity and various bloodborne factors in humans, there are some studies that say that having a little bit more IGF-1 is good. Other studies say having a little bit more IGF-1 is bad. But all studies tell you that having more insulin is bad. And unfortunately, growth hormone raises insulin, and nobody takes that into account. So we have to uncouple this confounding effect between insulin and growth hormone if we really understand what the potential of growth hormone is to do good things in the body. And so that's what we try to do, and the results indicate that we seem to be on the right track with this, that if you want to grow the thymus back, use a youthful milieu, use a hormonal context that exists when the thymus is in good shape in the first place. And that's not just growth hormone by itself, but growth hormone plus DHEA.
There's even a human study where, or at least a case study, where DHEA increased the size of the thymus.
I've not seen that study.
I've
seen the opposite. There's a book chapter and a whole book on DHEA by Kalimi and Riegelson, in which there's a whole chapter on DHEA in the thymus. And the DHEA had absolutely no effect on thymus regeneration. What it did do is protect the thymus against involution mediated by stress hormone, by cortisol. Mm. And that may be useful. So maybe if your thymus is transiently involuted by being super stressed out and you take DHEA, you might get a rebound effect, but that's not really the way to regenerate the thymus. Creon.
Hey, Greg. We were just exchanging emails, but it's nice to see you. Anyway, what about, how can I say this? There's things that are upstream of growth hormone. And are those things getting messed up as we age? And hence, what is causing the growth messed up? What is causing the growth hormone to go down? And rather than supplementing with growth hormone, maybe we could look upstream and supplement with something else. Or is it all just a bunch of cycles and you have to break in somewhere?
So I heard somebody say in one of these meetings before, in response to something that you said, that Creon is a brilliant guy. So I'm starting to understand why they say things like that. So growth hormone release is controlled by a balance between somatostatin and ghrelin, essentially. So you have hormones in the brain and in the hypothalamus and the pituitary that either inhibit growth hormone release or facilitate it. And with aging, the balance shifts more towards somatostatin. So it's a problem in the hypothalamus. We're basically slowly programmed to shut down growth hormone production. And there are ways of getting around that involving growth hormone releasers, but they don't work the same way in all people. And actually, I tried my favorite pick, a growth hormone releaser, on myself recently. It had absolutely no effect on IGF-1 levels. There are various ins and outs of that, and it's not a dead end. But for right now, we don't have a good way of bypassing the hypothalamus for everybody. It's something that we may be able to do in the future, but we're not quite there yet. If you're young, like if you're 50 or something like that, it might be a really good alternative. But if you're 70, it might be workable, but we're going to have to work out how to do it. It's not straightforward. You can't just take it for a little while and expect to see a result. There was a study published many, many years ago when they were first looking at these sorts of things, in which, I forget which releaser it was, it might have been Gorilla, I'm not sure, but they gave it for a little while and they got no effect, but they kept giving it, and eventually they could get release similar to what you get in a younger animal. So there may be some hope, but it will require some extra work. So for now, and that might be a lot cheaper approach, and that might be something to go to in the long run. And we're very much interested in that. We've looked at that fairly intensively, but we don't have an alternative yet. But yeah, first causes are always good to discover.
Thank you.
But for now, if you want to do something about your thymus today, the way to do it is the way we're doing it, I think, with growth hormone. And the main downside is the cost. We're working on that also, which is not easy, but we have some schemes for reducing the cost. And if we can actually ever get any investment in the company, we might be able to actually accomplish that and not only help people regenerate their thymus, but make a lot of money also. So
is that Intervene Immune?
Yeah, that's Intervene Immune. That's right.
And so you mentioned you have like follow-up studies going on, or follow-up trials. What's going on there? Could you give us an update?
Sure. So as you all know, we completed the TRIM trial. We published that last year. And it was very promising, but we didn't have any women in the trial. We didn't have any older men or any younger men in the trial. And we just got really lucky with the volunteers that came forward. People who are in the know enough to volunteer to have their thymus regenerated tend to be a cut above average, you might say, in many ways. They pay attention to what's going on and they pay attention to their health. And so they were really very, very healthy guys. And we were able to measure their biological age based on a variety of these epigenetic aging clocks. And they were all younger than their chronological age at the start of trial. So we were very lucky to have healthy people. And so that's another deficiency of the trial in a way, that we didn't have any sick people to look at, right? Because most people out there in the real world are not quite as on the ball as our guys, and they're not quite as healthy. So TRIM-X, which is the TRIM extension trial, is aimed at sort of correcting all of that. And so we'll have women in the trial, we'll have older and younger men, and we'll have people who almost unavoidably, largely because of their age, but for other reasons as well, will have less than perfect health. So we've begun enrolling people in the trial, and I see sort of two main branches of the trial. There's going to be one branch which is a pay-as-you-go kind of thing, because even though you would think that a therapy that looks like it can reverse human, at least epigenetic aging, would be the hottest investment topic out there, it isn't. So we have not done all that well as far as raising investment money. And so we can't really pay for the expenses of people entering TRIM-X. But we have applied for an NIA grant to fund TRIM-X also, and that will pay for at least part of the trial. So what I'm looking at now is having two branches. One will be the government paid branch, and that will be pretty much a strict replication of the TRIM trial, which is what has been called for. In science, you have to reproduce your results. But in medicine, you don't really care about reproducing your results as much as you care about helping people. And, we're just bursting with ideas as to how to make the TRIM protocol even better. And I just can't restrain myself. And so I figure that if you're going to end up having to pay for treatment, whereas other people might get it for free because they're waiting longer for our grant to come in, the least I can do is to augment what we did in TRIM to give you an even better outcome. So that's what we're planning to do. And so the trial will be broken up into several different subgroups. So the reference group is men between the ages of 50 and 65, which matches the TRIM group. So it enables us to make a direct comparison to TRIM, with one exception. So in TRIM, everybody by chance happened to be Caucasian and white Caucasian, not other kinds like Hispanics, for example. In TRIM-X, it's not going to be that way. So in TRIM-X, all of our treatment groups are going to be of mixed genetic backgrounds, mixed ethnicities. Our assumption is that it won't make much difference, because if we're applying a treatment to different racial groups in humans that is given to humans on the basis of results that you see in rats and cats and dogs, well, it seems like we're talking about some pretty deep biological principles. So it really shouldn't matter what your skin color is or that sort of thing. As long as you're human, that should do. So we will be testing that hypothesis. And hopefully—
And females?
Well, and for females too. So that's our second group is 50 to 65-year-old females. Right.
Dose of DHEA to females?
Yeah, well, you have to be careful about that, right? So females and males, I don't know if you guys have noticed it, but they're kind of different, right? There's certain differences.
I worry about a male dose of DHEA.
What's that?
I worry a little bit about a male dose of DHEA.
No, you don't want a male dose of DHEA, period. I'll tell you that right now. You don't. So there's still some nuance in the doses we can give ladies, but ladies do not need and do not want male doses of DHEA, because you guys convert, or you gals more properly, you convert that DHEA and all kinds of other stuff that we don't want. So, and males don't. I mean, we really don't. So it's a very different thing. That's a very different thing.
But are females as subject to hyperinsulinemia as males are under the same circumstances, or not?
So, this is a great question. We don't really know. So that's a thing about growth hormone. The literature is mostly about men. There's very little information about women. But the information that's available out there indicates that actually it's possible that women do not have the hyperinsulinemic effect of men. And so that may be a good thing, because we're going to be giving them a lot less growth hormone. I mean, DHEA, it's good if they don't actually need it that much. But, how do we control for being a woman, compared to being a man? That leads to really complicated questions with the third leg of our stool, which is metformin, because it turned out in TRIM that DHEA was not enough. We needed to, I think DHEA is enough in younger men, but it's not enough in older men. You need some help. So we blended metformin in as well. And what if metformin by itself does something radical, like reversing epigenetic aging? And we're just deluding ourselves to think that it might be related to growth hormone. Well, so if we don't give women the same dose of metformin as we give men, then maybe they would not experience reversal of epigenetic aging. Maybe they'll experience reversal of thymic aging, which would be great, but maybe they don't reverse their epigenetic aging, which would be terrible. We don't want that to happen to them. So we're planning to match as much as we can the metformin dose between men and women, so that at least they get that benefit, even though they would have to have a lower DHEA balance. Now, the DHEA question, by the way, is not so bad, because women don't need the extra DHEA. They have, the same kind of hormonal balance that they normally would have at a low DHEA dose. Let's put it this way: because of the conversion factor and so forth, they're fine with the lower DHEA. It's an imperfect balancing act to try to balance women against men and control for femaleness versus the other changes in the treatment regimen. But we're going to do the best we can on that. And then we'll have the older male group, which will be the fourth group. And then we're going to have some other interesting controls. So we're going to have 3 experimental groups and 3 control groups. One control group is no treatment at all. That's what you would normally think, right? Now, I can't expect somebody to pay for all the diagnostics that are required to do this trial and to pay to inject themselves with, some fake version of growth hormone or something like that, and then not give them growth hormone, right? So the control group in which you take nothing is not going to be a group that I ask anybody to pay to participate in. Let's put it that way. So that's where the NIA comes in. So if the National Institute on Aging pays for a study, we can pay people, hopefully, or otherwise induce people to be in the control group. And you're not going to get an injection because you're going to know that you're in the control group. And that's okay. It can't be placebo controlled because it's ridiculous to expect somebody to inject themselves 4 times a week for an entire year with salt water. I'm just not going to force that on people. It's unreasonable. So there's going to be a no treatment control group. There are going to be 2 modified treatment groups. One of them will be for men and one of them will be for women. And they will be the same as the full treatment group, except they won't include growth hormone. So we're going to try to parse out where the different effects are coming from by looking at metformin and DHEA alone or metformin and DHEA plus growth hormone. And that should give us some answers. So if it turns out that growth hormone is essential, we're going to learn something really important that kind of flies in the face of the usual idea that growth hormone is a pro-aging factor. If it turns out that growth hormone is not necessary, at least for epigenetic aging, then that'll tell us a lot about metformin and DHEA that we don't yet know. So we're going to win either way we look at this. But I can tell you one thing, and that is the controls are not going to have their thymuses regenerated, at least based on what we know today. And if they do, that'll be a big surprise, and that'll be great as well. But we can't expect that to happen.
Okay. Yeah, Creon, you go first.
Okay. One more question, Greg. It's kind of a general thing. Maybe others would want to speak to this as well. So at NASA, which is sort of where my life was spent for quite some time, when principal investigators and teams get grants and lots of money and they build spacecraft with instruments and they launch the instruments and they collect data, there's usually, although it's getting less common, an embargo period where they get to mine the data and publish some papers since they devoted 15 years of their life to this project. And then the data goes public and anybody can use it for their own science. Now, what I'm wondering is, we've had all these tons of studies over many years for all kinds of things, including metformin and other things. Now, does people's blood get banked in these studies so that at some time in the future, like if you want to check out metformin by itself, couldn't you potentially go back, get all kinds of blood from these metformin studies and the control arms, look at the epigenetic clocks, and you don't even have to do anything to anybody other than some run stuff through machines and do some data analysis. So is this idea, my question is, can you do this kind of thing with previously stored blood? Is that a thing that's done, at least starting to be done? And what's the deal on embargoing the data versus making the data public in these situations?
So those are actually 2 different questions, right? So storing blood for long periods of time is not necessarily something that's always done, right? Sometimes it is and sometimes it isn't. And if you can find a relevant study in which there are samples, then you can definitely go back retrospectively and analyze the data the way you say. And there are some studies that are designed for that sort of thing, but most studies are not designed for that sort of thing. And they're not so they wouldn't really be storing blood samples or other samples long term. So it's kind of hit or miss. So I haven't attempted to go back and look at that. We had some trial samples left over from TRIM, and we had a lot of people who were interested in analyzing them, and I promised to send out the samples, but it turned out that we didn't have enough money to pay Stanford to maintain the storage of the samples, and they got thrown out eventually. So it was a great loss. But it brings up a more general point, which is that it's not necessarily free to store blood samples. So if you have no immediate need for them, and you're not really thinking about somebody else's needs that might arise 20 years in the future, you don't have a strong incentive to undergo the overhead required to set valuable freezer space aside for samples you don't really need. So
do we have Mark Karakowski here from Forever Labs? Maybe Mark, we can. I thought Mark was here.
I am.
Mark, can you help?
Perhaps I can. I'm actually 2 minutes from jumping on a call, but yeah, absolutely. Greg, reach out to me, Mark at Forever Labs, or anybody else that it's relevant for. We might be able to help you out with long-term storage of blood or similar biologics.
Yeah.
So, yeah.
Okay, that's a great name, by the way, Forever Labs. I love that.
Thanks. And I'm just about to jump off, but I appreciate the call so far, and take care, everybody.
Well, Mark,
right. Take care, Mark. Thank you.
Mark, before you go, I mean, more broad than Greg, right? What about all the hospitals with COVID patients, right? This is similar to what Aubrey's change.org petition for. Like, can you reach out and get some people to store COVID blood samples for later analysis?
Yes, that's actually a very good. There's a couple angles that come from us with COVID that we haven't actioned anything yet, but yeah, we have docs that have seen them. We can start building that. It's not a bad idea, Karl. Thanks. All right, take care, everybody. Got to drop, but thank you. See you guys.
Thanks, Mark. We'll reach out. Okay, rolling back. I think one. So the change, what was the change.org thing? How can you maybe bring people up to speed for 1 second?
Aubrey is one of many people who put out a change.org thing a while ago saying that, data on COVID-19 patients should be openly available for people to analyze. And as far as I can tell, and maybe Aubrey can comment, I mean, it didn't really go anywhere. When I last looked, more than a month or two ago, it had like 1,100 signatures, was trying to get to 1,500 and wasn't getting a lot of traction. It was a great idea, and in general, it calls attention to a big problem in the pandemic, is that there's not enough data sharing. Like, there's lots and lots of hospitals, and I understand the hospitals, the frontline healthcare workers are just trying to keep people alive. But, one level back, there are lots of organizations with lots of medical records who are not publishing anonymized data sets or even, getting enough collaboration with researchers to do enough analyses.
Yeah, I don't recall being knowingly involved in that thing. Maybe I was involved subconsciously.
You're one of the signatories.
Yeah, that happens a lot. But certainly I'm very supportive of the concept, absolutely. Thanks for bringing it up, Karl.
Joe was here, I think, or maybe he just bowed out. One question, I think, Greg, when you were, sorry to take that back, unless someone wants to tag on that thread. One question that I think Karl was asking in the introductions, that when you were initially introduced yourself, was like, do you think that your research got any more traction since COVID-19 or not? And if so, to take that, to the topic of discussion that we had earlier, are there specific things that we could be doing now, if it's not the case, that would be useful to do in the context of COVID-19?
Well, what I can say, I guess, is that a lot of people noticed that thymus regeneration is relevant to COVID-19. And we've made that point in our NIA grant. So we hope that will bring some more credit to us in our struggle to get that funded. But in terms of, I'm not sure how to deal with the second part of your question. what else can be done, right? What do you mean by that exactly?
Well, I mean, the purpose of this whole group is like, can we get like by trying to share opportunities right now in which some of our work has already been accelerated by COVID, or if there's opportunities, is there anything that this group could be doing? If there isn't enough attention, are there any potential threads that we could be pulling to support that?
There probably is. It's hard for me to specify what that might be. I will say that we just published an editorial on thymus regeneration for prevention of COVID-19. Got published in Aging Albany and is available on PubMed as of a few days ago. So we're trying to spread the word in that way. And there was a nice editorial, I think, in The Lancet that made similar points. And other people are beginning to make points similar to that. David Sinclair just had a nice paper out with his coworkers talking about the importance of the immune system and indirectly, to some extent, the thymus. So I think people are beginning to catch on to that. And it may be, on a practical level, there's not a lot we can do to accelerate that much beyond what's already happening. Creon, what did you want to say?
And Karl, too.
Okay.
I want to mention a quick thing. This is not a question, but you might want to chime in on this. We were fortunate enough in the previous one of these group calls to have Gordon Lauk talk to us about glycomics and his thing. But one of the things he said, which was directly related to this, I think, and he's working with Sinclair, of course, and that is that they've actually, it's pre-publication, but they made a link between epigenetic clocks and COVID susceptibility. It's pretty damn strong. And they did it by getting some blood from a bunch of COVID patients. And so they link it through metabolic syndrome and stuff like this. But nonetheless, the methylation clock maybe has something to do with COVID susceptibility, whether it's a marker or a causative agent. Of course, I guess we don't know yet.
That's a fantastic link, and I appreciate you bringing that up. I wasn't really aware of that. I will check that out. Thank you.
So, I mean, this is a great thing, and we should have more. I mean, I think this would wake up everybody in the public. We've talked about this in this group before. Everyone knows age is a risk factor, and if we could replace it with epigenetic age and people understood the difference between biological age underlying and number of years since birth, that would be great. But parlaying on that, in terms of specifically thymic rejuvenation, Greg or Sarah, the thing about epigenetic age as a biomarker is it's pretty general, right? It's essentially just telling you really how old you are in an underlying way, in a very wide variety of ways. Greg, I think you're going to have trouble getting really short-term traction with anyone saying, "Oh, this is the TRIM trial type intervention is what we should be doing right now for COVID patients."
Correct.
Those people who are working on COVID aren't going to believe these kind of crazy aging community things. But
that's one thing. Is
there a good biomarker that's more specific to immune senescence that we could use, that's more specific than epigenetic age, that you could analyze blood samples or COVID patients' data with and come out with a study very, very quickly within months or something that would show that was a very, very, very high risk factor? That's what you would need to get buy-in for doing this. So what kind of biomarkers are specific markers of not just the thymic involution, which we know happens, but as you said, doesn't really affect until you're somewhere around 60, 65, but what are the real biomarkers underlying that would be really predictive of COVID-19 severity?
One thing that's really obvious, we already know is predictive of COVID-19, is IL-6 levels, which I think correlate with some of this immunosenescence. And look at how many T cells you have. Look at your lymphocyte counts. Then also look at look at NK activity. These are all very generic, but some of them are known to correlate with COVID risk, and some of them I would very strongly predict would correlate with COVID risk because they all kind of move in the same direction over time. And you're right. That is a thing that you could test improving after a growth hormone trial. Yeah.
I think that all of that's correct. We actually have some ideas along this line. And one of the things that we didn't have in TRIM that we're going to have in TRIM-X is not just measures of whether you're producing more naive T cells or not, that sort of thing, but also the function of those T cells, right? So the thing about COVID, SARS-CoV-2, is that it's similar to SARS-CoV-1. And if you look at what we know about SARS-CoV-1, what we know, sorry about that, let me kill off the cell phone. What we know is that, and I think this is true for flu also, that your actual risk of disease is correlated much more strongly with the existence of SARS-CoV-1 specific T cells than it is with, for example, antibodies against the virus. And so normally when you're looking for a vaccine response, for example, you're looking at an antibody response, and that does correlate with the outcomes, and that's very well and good. But the real key thing is your T cell, but not just general T cells, not just T cell numbers, because from T cell numbers, you can't really tell about the quality of the T cells. You could have a large number of T cells that are just not very good. And so we did measure senescent T cells in TRIM-X and exhausted T cells, and specifically saw that T cells that are PD-1 positive tend to go down with treatment, and PD-1 is an immunosuppressive marker. But what we didn't do is challenge the T cells with antigen to see if they would respond better. So there's two ways to do that. And it's a classic assay in immunology, and even in the immunology of aging, to stimulate the T cells with these generic antigens that cause the T cells to proliferate. And essentially, it's a test of the ability of the T cell to respond to a foreign antigen and then do what T cells must do to protect you, which is to expand, to become more plentiful in your bloodstream so that there's enough of them to kill off whatever is invading you. And so we already have built into TRIM-X T cell proliferation assays, so that we can see not only if your naive T cells are coming up, but if those cells work better. So what I shouldn't tell you, but I guess I'm going to have to tell you now because you asked me, is that there's a way to make that test specific for SARS-CoV-2, and we want to do that. But we're not quite there yet, but we have everything ready to go, so we could run those tests very quickly. And it wouldn't take too much to go from there to running those tests with and without treatment, or with and without different kinds of treatment. So, we could end up with something very specific to COVID-19 pretty quickly. However, we still go back to your first point, which is that COVID-19 people may still not be all that excited about what we're doing, not for two reasons, not just because it's some kind of crazy aging stuff and not really related to viral, biology the way they're used to, but also, unfortunately, in TRIM, what we found is that if you're 65 and your thymus started involuting, let's say when you were 15, you've had 50 years of thymic involution accumulated up to that point that we're trying to overcome in a year. And it turns out that it looks like it takes about maybe 6 months or more like what we demonstrated, which is 9 months to overcome that. And so if you are dying of a disease that's going to kill you in a couple of weeks, you can't really wait for 6 or 9 months for a treatment. So we have to envision thymus regeneration more as of a preventive medicine approach to COVID and other maladies like that, rather than as a treatment for it. And it's always a challenge to get people to pay attention to preventive medicine. because doctors like to cure diseases rather than prevent them. It's just because that's historically the way things have gone. But I think everybody wants a vaccine for this particular virus, and so everybody can understand the value of prevention in this case. And the beauty of this is that if we can regenerate the thymus and show that that affects COVID-19, for example, this particular SARS-CoV-2, then the implication is, of course, that it will also positively impact all other viruses as well, or almost all other viruses, as well as other nasty things like antibiotic-resistant bacteria, for which we have no drug therapy, that will tend to be a problem more and more in the future as we go forward. But your immune system doesn't care whether the bacteria resists an antibiotic or not. It'll still be able to kill off that bacterium. So once we establish the principle of prevention of one disease, then it's pretty obvious that it will prevent a large number of other diseases. And I think that's where the traction will come in.
So now that we're moving from the what can we do right away in months and squash the pandemic to the what are you going to do that's going to help fix the next pandemic,
Yes.
The discussion, just for those people who don't know, which I don't think is very many of you, wouldn't be complete without quick mention of some of the other companies that are doing things to rejuvenate the thymus, specifically, besides Intervene Immune, specifically, but who aren't on the call, specifically Ligenesis, which is funded by Juvenescence, is working on ectopic growth of new thymic tissue within the lymph system, which is not going to be ready in time to squash COVID-19 during 2020, but I believe they're going to start clinical trials in 2021 unless they've been delayed significantly by the pandemic. And Reason's company Repair Bio is working on thymic rejuvenation with upregulation of FOXN1. But again, it's not, these things are not going to be quick.
I should mention, actually, Karl and everybody, with regard to Repair, so I'm on their scientific advisory board, so I have reasonably up-to-date information here. They've actually decided to shelve the thymus project right now because they are short of money, and they basically want to focus on their other strand of their work, the senescent cells, for the moment, just in order to, to get through the funding dip that they are experiencing. So, I should let everybody know that if we want thymic work by Repair to resume quickly, then that's the main stumbling block right now.
Yes, the irony is that the pandemic of an infectious disease is causing the work on thymic repair to go on hold.
That is ironic. Yeah. How about the other company? Would you like to say more about the other company?
Yeah, I can say more about that, sure. I introduced Ligenesis to Juvenescence right at the beginning when Juvenescence had just come into existence. And it was one of the first groups that they essentially turned into a company by essentially buying a controlling stake. They are based on the work of a professor in Pittsburgh named Eric Lagasse, who has been working on the general idea of repurposing lymph nodes for a long time. Most of the work that's happened there has been with respect to creating mini livers out of lymph nodes in situ, in vivo. But in parallel with that, there was work on the thymus, which is going very well. I don't have any up-to-date information there, so I don't know whether the liver or the thymus work is going to be the first to go into the clinic. But yes, I have the same understanding as Karl that the clinic is not very far off.
It'll be very interesting to see. I don't know anything about them, so I can't comment further, unfortunately. Sorry about that.
Yeah, well, Greg, once you have more to share on what you're getting ready right now with COVID-19, please let this group know if we can help, and Aubrey, please share too. I think, to the correction that Nicolina made in the chat previously about the methylation clocks, it's definitely glycan age. And also, this is for me one intervention of asking you who here has gotten their glycan age test. I did. Anyone else? I know that a few on this call have done so.
Have you also had a methylation clock to compare?
No, also it didn't arrive yet. I just recently ordered it. So, here we go.
I got mine.
Okay, good. I will share in the chat again.
I got mine, Allison.
You guys are going to do the glycan age test. If you've ordered the test but not actually done the sampling yet, you should order Elysium's index methylation clock test as well, and take them on the same day, and you can compare the results.
Okay.
Cool. Thank you.
Will do. Thank you. Will do. And that brings me also back to the question to you, Greg. You mentioned people can participate if they self-pay. Is that still an option?
Yeah, no, we're still actively enrolling. It's a process, but we're going through it. Several people have had their blood tested and have passed the test. We actually have had to reject a couple people. We actually found that one of the people who applied to get in, who looked pretty good on his online questionnaire, turned out to have markers that made me suspect that he had prostate cancer, and we referred him to the best place to check into that. Turned out he did have it. But he's a young guy, and he hopefully will survive as a result of trying to get into our trial unsuccessfully. So even if you don't get in, there may be benefits to trying to get in. Hopefully not that one for most people. That's a pretty tragic thing, but I hope that he'll be okay. That's a treatable disease. But so we're enrolling people currently. We haven't really done anything in the way of advertising or that sort of thing. It's all been pretty much word of mouth and referrals from RadFest and things like that. But anyone who's interested in carrying the freight of their own weight to have their thymus regrown is welcome to contact us. And we'll send out an online questionnaire, which just asks about your general health and various things that may exclude you from the trial. Most of the people do not get excluded, but some people do. And once we look at your online questionnaire, then we can send you forms to have your blood tested. It costs about $500 for the blood test, but it's a very comprehensive test and specialized test that measures T-cell subpopulations and things like that, which are not normally looked at. And then once you pass that, then you can move on to the next stages of enrollment, which involves an online physical through our trial physician. He has recently decided that he would like the participants, if all possible, to submit their medical histories, which will enrich our database and enrich our ability to look at before and after differences. And just as a physician, will give him a better idea as to who he's dealing with. Karl.
Greg, 2 questions. Are you planning to retest the original 9 or 10 TRIM folks several years later with methylation clock and with these battery of the full panel of tests again? Is that on the plans?
Yeah. So we would love to retest our guys for more reasons than one. And a number of people have asked, well, how did they do, long run? And we really haven't followed up with them. So we'd love to do that. All I can tell you is I haven't heard anything bad from any of them. But
have any of them gotten COVID-19?
Not to my knowledge. And probably if one of them had, I would find out. But, I just haven't heard that.
Okay, separate question. Have you talked to Steve Horvath about the way these methylation clocks are trained with machine learning, is to, first they were trained to predict biological age, number of years since birth. And then, we've got the sort of the more grim version is the sort of predict time till death. These are just machine learning systems, learning associations. If your goal is specifically immune rather than all-cause mortality, you could have a different training signal as long as you have enough data. Have you talked to him about training a different methylation clock that was immune specific, essentially an immune clock, but built with the methylation data?
That's a brilliant suggestion and question. And the answer is no, I have not. However, right now, something is being set up it'll be a nonprofit foundation that is intended to expand the use of epigenetic clocks for all kinds of purposes and to encourage their use as much as possible. And it's very possible that there's already plans like that have not been shared with me. But if not, I will make sure that there are, because that's a really great idea.
Steve is behind that himself? Who are the people doing that, setting that up?
Well, actually, I'm not sure if I should say, but I guess I wasn't exactly sworn to secrecy. Let's put it this way. There's a person of significant wealth who's behind setting up that foundation. And Steve is involved in that. And the CEO of Intervene Immune is also coordinating and chairing that organization as well. So he's wearing two hats, one nonprofit and one for-profit, but we'll try to prevent any conflicts of interest.
Greg, can you tell us the name of the nonprofit?
I'm not sure if I am allowed to spread this information around, so it's probably safer for me to hold off for now and then maybe bring it up in a couple of weeks once I verify that it's okay to tell you.
And do you know?
It's possible I shouldn't have even told you what I have told you, but I don't see the harm in it.
Is this likely to be public within a month? What's the time frame?
I don't know, but chances are pretty good that I'll be able to tell you in much less than that. How about that?
That sounds lovely. Yes. Yes,
it's a great idea. It makes a lot of sense. It's largely intended to facilitate clinical trials so that anyone who's doing a clinical trial realizes that they can include epigenetic age as an endpoint of their trial. And this could be, significant in all kinds of unforeseen ways. Let's say that you're developing a new kind of toothpaste or something, and it turns out it reverses epigenetic aging. You would never know. But, if you can run that on the side without breaking the bank and discover it by accident, that would be a really great thing. Probably toothpaste is not a good example, but you get the idea.
Well, it's also super important for all trials, just the way they analyze effect versus age that they might have, though they should be analyzing it versus epigenetic age or biology.
Yeah. This is kind of along the same lines that Sarah was talking about, in which you look for drugs that are developed for other purposes to see if they have anti-aging effects. But how do you tell? Well, epigenetic aging is probably the best way, at least in terms of something that's quick and easy. And it's less expensive than a mouse longevity study, although you still want the latter.
Okay, that also brings me back to something that has been popping up now in this discussion in the previous meetings over and over again, which is something like kind of like a health commons that, either as a thing kind of like to advance more generally or even amongst this group, because it does feel like a lot of people are kind of like individually. I would guess that a few people are already who are in this group are already enrolled in your trials, but then maybe a few others have got the glycan age test and so on. So I think it would be interesting to kind of like discuss that potentially a future meeting. I realize Sarah has dropped, which is no surprise because we're now 23 minutes over time. But is there anything else you would want to surface in relation to the topic of today, in relation to how we can help you with your specific with your specific project?
Well, let me just say one thing, and that is that we've had to make some adjustments in the way we do things for TRIM-X compared to TRIM. The main adjustment is due, once again, to COVID-19. Guess what? Because in TRIM itself, we had everybody gather together. And so we had to have people travel. And traveling is more of a problem these days than it used to be. Plus, it's expensive, and not everybody wants to afford to, have a costly plane ticket from Florida to California or whatever. So TRIM-X is being done by telemedicine methods, which means that anyone can participate within the United States. And we're trying to expand our reach to Europe as well. There's a lot of interest in Germany, for example, but also other places in Europe. And what we require in order to go beyond the United States is the connection with the local blood testing lab that will share samples with us and share results with us, because we have accounts with Quest Diagnostics in the United States that allow us to have people have their blood collected in any of the 50 states and the results transmitted to us. Now, there's a complication with overseas participation and even within the United States to some extent in one respect, and that is for some of the assays, like the T-cell functional test that we're talking about, the age of the T-cell, the time from collection of the blood to time to testing of the sample may be an important factor. So in some ways we can, like if you're within most of the 50 states, the lower 48, you can have a sample taken in Florida and received at the lab 24 hours later, and that should be good enough. But if you're in Rome or if you're in Hawaii or whatever, I'm not totally sure if the logistics will be quite the same. Probably from Hawaii they would be, but if you have to go through customs or whatnot, it might slow things down. The main point, though, is that with minor, wrinkles like that aside, the trial is really open to anyone, anywhere, and we welcome anyone who would have an interest in with potentially participating to contact us. I think you all have my email address, so I don't need to tell you what that is. But the overall cost is not all that cheap right now. We estimate it to be on the order of $17,000 for a 1-year course of treatment. And that's partly because the cost of growth hormone is pretty high, and our growth hormone supplier that was willing to give it to us at discount prices has recently kind of reneged on that offer, so the price may be a little higher than what we wanted. And also, we, at this stage of the game, still want to have pretty heavy diagnostic work done, so we can make sure that what we're doing is working and that we can make sure that it's safe. And all of that costs money that we don't have, so it all adds up. As we get into a clinical stage of this treatment, all of these costs will come way down for all kinds of reasons. But for right now, as a research stage, that's the kind of price tag that we're talking about.
Yeah, I feel Marty.
Hey, Marty. Great to see you, Marty.
You're
still
muted.
You have to unmute yourself. Down at the bottom of the screen.
I'm trying to unmute it right now.
Okay. Almost.
Now we're playing a mute game. Okay, great. Okay. Here you go.
Hey, Marty.
You're still muted, even though you're not on the camera.
Uh-oh.
Maybe it's the headset.
Maybe
until he's figuring out. Keith had a question of, does the NIH, all of us... Oh, there he goes.
Will growth hormone releasing peptide work?
I'm sorry, say that again?
Will growth hormone releasing peptide work?
That's the sort of topic that we were talking about before.
The one that they made at SmithKline and Beckman before that? Frank Maimonides.
There's all kinds of ifs, ands, or buts about these sorts of things. So strangely and bizarrely, and I really don't have any explanation for this, and I haven't heard anyone else explain it either, but it's possible to release growth hormone without elevating IGF-1. And a lot of these peptides and things like you see on television, like Serovital, Kim Douglas out there saying, hey, what if there was something that could make you look not years younger, but decades younger? Interested? Well, those are all cheapo growth hormone releasers that don't raise IGF-1, and I don't think they will be effective in this application. By the way, Dirk Pearson and Sandy Shaw were big into growth hormone when they published their wonderful book, Life Extension, A Practical Scientific Approach, long ago, and going on the Merv Griffin show all the time and making aging really popular topic. But I found that if you use arginine to release growth hormone, it makes your IGF-1 levels go down. And I actually did some blood spiking experiments on myself in which I spiked my own blood sample with arginine before sending it off to the blood testing lab to see if it was just interfering with the assay. And no, it doesn't interfere with the assay. It just prevents growth hormone from raising your IGF-1 levels. It actually makes it go down. So just releasing growth hormone is not necessarily enough. And so it turns out to be amazingly complicated. And And we're very interested in working our way through all of this stuff and coming up with the best solutions. But for the moment, the only practical way to know that, what you're really doing and guarantee it's going to work for everybody is growth hormone itself.
Well, I made about 1 kilo of that stuff once, and I still got some samples sitting in my freezer.
Well, send us some, because I may be a fool, but I always test everything on myself first, because I don't want to give anything to anybody else that might not work or might have hazard associated with them. So I'm willing to be a guinea pig if you have some that you don't think is going to kill me.
Yeah, Life powder, we made it for NIH, and it's been sitting for a long time, but I looked at it not long ago, and it still looks like nice white fluffy powder.
Oh, that's another one for the...
Hard to say if is it stored under vacuum?
No.
So it could be oxidized over time.
The trip could have oxidized, but...
Well, maybe I could run through some through our HPLC and find out.
Yeah, usually these things look yellow when they oxidize, though.
Well, send me some. Send me some.
Well, that's another one for the Foresight Health Commons. Another one to add to the list.
Keith, did you want to say something?
Yeah, I had just mentioned when there was some talk earlier about setting up like a commons for health data. And I was just curious if anyone here was familiar with the NIH All of Us initiative. I'm pasting the link right now. I actually wasn't aware of this until just a few days ago, so I'm digging into it now. But I noticed also in Apple's recent announcement a few days ago, their WWDC event with all the health kit and research kit on the phones, they had mentioned this app as one of like the flagships. And it looks like it's an initiative meant to collect data from, in a sense, like a crowdsourced initiative that has a goal of collecting health data from 1 million citizens to make available to researchers. So I'm going to look into it, but I'm just curious if maybe, what kinds of data? Is it just surveys, or is there a way where we can somehow have some sort of use, a biomarker that would be useful to us to somehow make it as part of this initiative that might serve the health commons idea? So I'm still looking into it, but I just wanted to make everyone aware that that's a thing if we didn't know that.
Wow.
Yeah.
Yeah, thanks for sharing.
Thanks for sharing.
I think Brian Delaney's not on the call this week, but I mean, he and Bill Falloon are involved in something. Hong Jiang in the Bay Area is involved as well, where they're trying to do this, but with a longevity angle.
Right.
That's another effort, and they have Bill Falloon's got money, and I think they have an official nonprofit name, but I don't know where it is with COVID.
Yeah, and I'm going to talk to Ron Kohansky in the next couple of weeks, so I can ask him, is the NIA involved in this broader NIH initiative in any way or not, or I'll find out. So.
Okay, I will reach out also to the names that you mentioned, taking notes, because that brings us nicely into, we're now at 30 minutes over time. I think that we, one of the potential future topics could be just discussing a potential health commons. Maybe I'll get Hong and a few others involved to see what their efforts are for this. And maybe, I don't know, maybe we can fit the NIH initiative in there too. But kind of like a larger point that I wanted to make, which was the housekeeping thing, which we're probably not going to go to today because to save all of our energies. But let's do it as a homework instead. So I have the poll, right, that I always ask at the beginning of this meeting. I'm going to end the poll now, so no one can contribute anymore. I'm going to share the results with all of you. And so you can kind of see what people here are interested in terms of the question number 3, I'm interested in, and then it's a multiple choice one, right? And so you can already see, kind of like where everyone here is falling on the call. But, and this usually, when I ask that question, that helps me guide kind of future meetings and what we're doing in future meetings. So what I'm hoping that this entices all of you to do is, I am now sharing the spreadsheet that I use to kind of like help me a little bit in what we should be discussing at future meetings. And it would be amazing if until next Friday, you could do a little homework, which is A, on that spreadsheet. It should link you directly into promising aging threads. That's basically just what you just wrote it on. So just add what other topics you think would be of value there, right? Or if you want a +1, there's a comment section for that now, or suggest a name for who should be leading a session on that. So you can kind of like, really shape what we're going to be discussing over the next few weeks. Okay. And then, of course, there's also a collaboration doc on which you can fill in who you are, what you need, what your affiliation is, and your email. And then I'm hoping that, over the next few weeks, what we could be doing maybe at the beginning or at the end of those meetings is more, if anyone has an update here that they want to share that's relevant to the group, we can do like a little bit more free flow sharing sessions. So we all get to kind of like have more of a back and forth between this group, and we can help each other a little bit more. Okay, so that's my hope and dreams for next week. Here's so please, everyone do me a big favor, please fill out the aging and COVID promising threads thing if there's things that we should be discussing, and add your name to the collaboration thing if it's useful to you, right? Only if it's useful to you. And then we can kind of like make that into more of a responsive situation. And if there's someone who should be in this group who isn't, nominate them to me. I usually get 1 or 2 nominations after each call, and so we're slowly growing this with a high trust container. Final question, Greg. So yes. This meeting is recorded in the background, and afterwards we always decide whether to publish or not. Like, given everything that you said and how unsure you were about any of this, I'm assuming that we're going to do nothing with the recording for now. But if you do think back and think that at least the recording, perhaps, for example, would be useful for this group to have, with a follow-up, for example, to ask people to sign up to that study, and here, if they want to know what this is about, here's the recording, then we can release it, for example, in an unlisted way where it's not public on the internet, but only available to people in this group. I don't know. Right. It's up to you.
Yeah, I appreciate that. So let me pound heads together with Bobby for a while, and then I'll come back to you with that. But I appreciate that. So yeah.
Okay. Super. If it's useful to provide context, then we can definitely go this way. And also, please share any links and any follow-ups already that I can be sharing with the group. That would be useful to have without the links too. Because I'm assuming that a lot of people here, myself included, are very interested in signing up. Okay, well, very nice. Thank you so much for staying on for 37 minutes longer than we initially planned to. Thank you so much for chiming in, Greg, and making time.
You're welcome.
I know that's much appreciated by everyone here. And I'm hoping to see all of you again next Friday. And please help me shape what this container becomes by putting in the collaboration and what we should be discussing. So thank you, everyone. Have a lovely Friday.
Allison.
And Greg, I hope to hear from you. Bye-bye.
Thank you. Bye, everybody. Take care.
I'm opening breakout rooms if people want to hop into those, but this is the official closing on my end. All righty.
All right.
Okay.
Take care.
Take care. Bye.